Welcome. Today we'll solve a limit problem as x approaches infinity. Let's find a limit as x approaches infinity of the fraction 3x squared plus x plus 1 divided by 2x squared minus 1. When finding limits as x approaches infinity, we need to look at the highest power of x in both the numerator and denominator. In this case, the highest power in both the numerator and denominator is x squared. To solve this limit, we can divide both the numerator and denominator by the highest power of x, which is x squared. This will help us see what happens as x approaches infinity. After dividing by x squared, we get 3 plus 1 over x plus 1 over x squared in the numerator and 2 minus 1 over x squared in the denominator. Now, as x approaches infinity, what happens to terms with x in the denominator? 1 over x approaches 0, and 1 over x squared approaches 0 even faster. Therefore, as x approaches infinity, our fraction approaches 3 divided by 2, or 1.5. Let's visualize this limit with a graph. As x gets larger and larger, you can see that the function approaches the horizontal asymptote at y equals 3 over 2. In conclusion, when finding limits as x approaches infinity for rational functions, divide both numerator and denominator by the highest power of x, and then evaluate what happens to each term as x approaches infinity.